Hello friends, my name is Sumit and I am here to share an information video on pressure. So first of all, when the pressure comes, where we are using pressure? We are using pressure in our process industries and every day-to-day life where we want to measure the exact pressure of that the surroundings or any liquid, any gases. Actually, measuredly we use pressure in liquid and gases. Sometimes in solid substance also, like wheat and or solid grains and all. So, what is the definition of pressure? First of all, as we can see, pressure is defined as equal to force upon area. That how much force you are exerting on a particular area. If that area is small and force is more, then your pressure will be high. Like the same thing happened to our earth also. Air pressure, gases and all. These all are the pressure which is exerted on our gases, on our earth, and that we call as an atmospheric pressure, and that is counted as 1 atmospheric pressure. Okay, but for pressure, what are the terms that we are using for pressure? So what are the different terms that we are using? And pressure are, first, as I said you, atmospheric pressure. Second, absolute pressure. What is absolute pressure? And there is a difference between absolute and gauge pressure that I will show you in the next slide. But for the information, absolute pressure in which we consider atmospheric pressure in that we take atmospheric pressure, and in gauge pressure we neglect the atmospheric pressure and start from our pressure readings from atmospheric. Third is total vacuum. When there is no atmospheric pressure, then that system is called total vacuum system. But if there is little bit of less than air pressure, whatever the pressure, negative pressure is there on the earth, less than atmospheric pressure, that system is called, or that scenario is called as under vacuum system. Like there is some vacuum there. Same thing like on other planets where there is no air. So that system is vacuum. Last is differential pressure. So this pressure terms we used in so many different applications where we use pressure as to measure some different things like flow and level. There we use this differential pressure terms. Okay, so let's take the pictorial view of how does it looks. So if we consider zero, like there is no pressure, then that is called as I told you, total vacuum system. And what we discussed that there is 1 atmospheric pressure on our earth. So let's consider 1 atmospheric pressure. So this is our base of vacuum and atmospheric pressure. So what will be the condition? As I told you that whatever is in between of atmospheric and total vacuum, that is called as under vacuum. Means that is a vacuum system. Next is, as I told you, for absolute, let us consider one reference point as A, which is above atmospheric pressure. Then what will be the absolute pressure? As you can see in this formula, that absolute pressure is equal to atmospheric pressure plus gauge pressure. Whatever the pressure above atmospheric, that is called gauge pressure. So it will be, we will consider 1. So this pressure is 1 atmospheric pressure plus 1 pressure above that, that is 2 bar absolute. And if we consider what is the gauge pressure, then as you can see in the formula, that is absolute pressure minus atmospheric pressure. So what is absolute pressure here? That is 2 bar absolute. And if we minus 1 atmospheric pressure from that, then that will be considered as 1 bar gauge. So this pressure is 1 bar gauge. So next thing, what if any pressure is in between atmospheric and total vacuum? Let's consider this point B, that is like above, less than atmospheric pressure and little bit more than total vacuum, that is 0.5. So what will be the absolute pressure for this and gauge pressure for this? So absolute pressure will be 0.5 bar absolute pressure, and gauge pressure will be minus 0.5 bar gauge pressure. Okay, so this is the whole pictorial view. You can see here I have shown you total vacuum, under vacuum, atmospheric, absolute, and gauge pressure. Last is differential pressure. How differential pressure? What are the differential pressure and where we use differential pressure? Normally we use in, let's say if there is a pipe with having reduced the area, so there will be 2 points P1 and P2 will be the pressure points, and if some, let's say some flow is following through, so what will the differential pressure here is P1 minus P2. By that means we can also calculate the flow flowing through the pipe. Same thing if we take pressure units. What are the different pressure units we have? So pressure units are PSI, pound per square inch, then Pascal, Newton per meter square, torr, 1 mmHg, torr is equal to 1 mmHg. This term actually we use for vacuum, to calculate the vacuum. Then atmospheric and bar. So bar is equal to 0.9869 of atmospheric pressure. So let us see the conversion rate of pressure. And if we consider 1 atmospheric pressure, then which is equal to 1.013 bar, and for Pascal it will be 1.101325 Pascal. Same will be for Newton per meter square, because Pascal is nothing but Newton per meter square. For mmHg, millimeter of mercury, it will be 760. For torr, as millimeter mmHg is equal to 1 torr, it will be 760 torr. For m of H2O is meter of water column, that is 10.4 meter of water column is equal to 1 atmospheric pressure. And this we mostly consider this pressure in levels. And last but not the least is PSI, pound per square inch, which is 14.75. So thank you friends for watching this.